Okay, so here's just a little reminder for you. When you're solving for variables, when you're solving multiplication problems, you're going to use division. When you're solving division, you're going to use multiplication. When you're solving addition, you're going to use subtraction. When you're solving subtraction, you're going to use addition. So the reason behind that is because you want to use those identity properties. The identity property of multiplication is the same for division, and it's 1 times anything equals that anything. So 1 times x equals x. Okay, you isolate that variable. And then the identity property for addition, same for subtraction, is that you want to get that to be a 0. So you have 0 plus x equals x. Okay, this is how you isolate the variable, and that's what the concept is. It's isolation of the variable. You're isolating the variable by using the identity property of multiplication and by using the identity property of addition, and you're applying that to both sides of an equation, right? So your equations have to be equal on both sides. Otherwise, that equal sign is irrelevant. Okay, so before we go on to lesson 5, let's practice a few of these. Let's say I have 5 plus x equals 9. So this here is a positive number, so that makes that an addition equation. So in order to solve for this, I'm going to subtract 5. When I subtract 5, I'm left with a 0. I subtract 5 on this side. 9 minus 5 is 4. This gives me x by itself, and I have x equals 4. If I substitute 4 up here for the original equation, I have 5 plus 4 equals 9. True statement. It doesn't matter where the x is. You're looking at the number to decide whether you're adding or subtracting. All right, so let's take x minus 12 equals 4. You're going, oh, it's 3. Well, no, because 3 minus 12 gives you a negative number. So right here, I'm looking at this. I'm like, oh, this is a negative 12. So in order to get to a 0, I have to add 12. I have to add 12 to this side because this has to stay equal. That becomes 0. This becomes 16. Okay, so substitution, 16 minus 12 equals 4. True statement. Okay, next let's look at multiplication and division. Okay, so 3x equals 15. 3 times x equals 15. This is multiplication. I need to find the identity property of multiplication. Therefore, I divide by 3. Okay, this becomes a 1. I divide by 3 over here. X is now by itself because 1 times x equals anything. 15 divided by 3 is 5. If I substitute the 5 for the x, I get 3 times 5 equals 15. True statement. Okay, and then finally division. I'm applying the same principle as I did to multiplication. I want to use the identity property of multiplication. So I have x divided by 4 equals 5. So in order for me to, this is a division because this tells me it's division. It's also the same thing as 1/4 x. So this could be written like this as well. But in either case, I'm still using multiplication because it's the reciprocal. Okay, so what I'm left with over here is 4x over 4 equals 5 times 4. Same thing over here. 4x over 4 equals 5 times 4. This is a 1. This is a 1. X equals 20. I suggest you put this 1 here so that you know, so that you can recognize, make sure you're dividing by the right thing. If you divide 4 by 4, you get 1. So make sure that you're looking at that and going, oh yeah, 4 divided by 4 is 1. Okay, not that you're putting like a 3 or a 2 or something there, because you want this to be a 1.